Welcome to Coffee with Prosys OPC, a podcast hosted by Prosys OPC's very own experts, CEO Pyry Grönholm and CTO Jouni Aro. In each episode, our hosts discuss everything related to OPC UA and Industry 4.0 with leading experts from all over the industry while enjoying a cup of coffee. Stay with us to learn more about Prosys OPC and the intriguing advancements on the convergence of IT and machines.
Welcome to the first episode of Coffee with Prosys. My name is Pyry Grönholm and I'm CEO of the Prosys OPC, and here with me is our CTO Jouni Aro, which will be also hosting some of the episodes in future. In this episode we plan to a little bit cover the history of our company and why we are one of the key technology providers for the OPC UA and why did we end up in this position. But hey, if we start with little introduction anyway about ourselves, but Jouni, if you tell a little bit about your background and probably at the same time a little bit the history, how even our company ended up in the OPC UA world.
Yeah, well, that's a long history we already have. We started in the 1990s, and I actually started working on my master's thesis at the university, and at the same time I was introduced to Prosys, where we started working on some software development for the automation industry or the industrial software development, and it was quite interesting to start working with real projects, and of course we had quite a lot of challenges right from the start, but yeah, since then I've been kind of working, being responsible of the development of our products, and recently it's been concentrating on the OPC UA development, and eventually we became experts in OPC because OPC was very useful for us in our first projects, and it was kind of OPC was established around the same time as Prosys, and therefore it was a natural thing for us to start using it, and we're still on the same journey.
Exactly, and like when Jouni joined the company, something like in 1996, I joined only 1 year later, but although I was a summer trainee at that point, and in my background, like I've been more like the end user of the OPC UA and OPC, well, for most of my career, where I've been working with the customer projects, where we have been utilizing the technologies and SDK and all that provided by our R&D team. If we go a little bit back to the history, I recall like our first customers, like the reason that we ended up actually using Delphi was that for some reason like the existing tools for SCADA development were not good enough, and it was a little bit like an accident almost that we ended up programming and not just using package software.
Yeah, that's actually quite an interesting story. So I just got into this project with our first customer, a Finnish company called Scienta that was producing measurement scanners for like online measurement systems, and they had a challenge for us to develop a monitoring application, and they had chosen software from a major automation vendor called Siemens, and they were using Siemens PLCs for the control of the scanner, but then we just needed to add some decent control software that would show results of the scanner, and the main result of the scanner is a profile. It measures like basis weight measurements and moisture measurements of paper, but actually Sienta was more working with impregnated paper production processes and things like that. But Siemens had a brand new product called WinCC that we were supposed to use for the first projects, but actually it turned out that WinCC was not quite ready yet. So we had a beta version, and there was challenges to get all the features that we needed. And the first thing that I tried to reestablish was a graph component that we can add to the WinCC. I managed to program that as my first job, and soon it was discovered that even that was not enough. We had to actually replace the whole WinCC because the other functions were not ready enough yet, and there was pretty tight schedule for this customer. And then I brought up this idea that I had heard of a tool called Delphi, and I knew that everything is possible with Delphi, and you just need to program it yourself. But we were free to do whatever instead of trying to figure out what in the tool works and what not. So we started this project, and we had a deadline of 2 weeks to bring out the first prototype of the product, and we made it, and then we were in trouble. Because then we had to deliver the final program as well, and there was still a few months to do that. But that's how we started with Delphi development.
Yeah, and it was quite an adventure, like installing like the software at the customer site in the world without laptop, but just desktop computers and all that. When we started to work then with Delphi in other projects as well, and soon like it became evident that OPC was the best way to connect like PLC of different vendors, and like while we were working with those OPC connections for the customers, at some point we realized that hey, why not create like a component for OPC communication for the Delphi. And that's probably because in Delphi there is a lot of component libraries, but not really anything for the OPC at that point. But
yeah, Delphi was actually a superior tool in 1990s. I remember the first year I was kind of fighting against the idea that I have to program with Pascal instead of C++. But after I got into that, I was really happy that I didn't need to program C++ anymore. Could do all the same things with much more kind of manageable environment. And the best thing with Delphi was that it had a great set of components already. It was very popular in 1990s, so there's a lot of people bringing out components for different tasks. And it's kind of comparable to what you have today for .NET and Java, which were actually both developed from the ideas of Delphi. Actually, the .NET developer, the main developer, Anders Heisberg, was the original developer of Delphi. So he was just continuing that when he went to Microsoft and developed .NET over there. But Delphi was really successful with these component frameworks, and actually not so many people know it still is. But therefore, after working with some customers with the OPC development, I kind of realized that this is something that makes sense, that instead of rewriting the same thing every time for different customers, it makes sense to put effort in bringing out components and like naturally bring it into Delphi as a programming element. And eventually we managed to do that, and that product is still in the market. It's called Prosys Central.
At that point, it was kind of like our entry to the OPC SDK market and our first product that we started to actually license for other developers. And we used that successfully ourselves, and we got even some customers for that. still, like, it didn't take long before everyone realized that the old or OPC Classic, that how we call it now, the old OPC was about to became like obsolete at some point, and new OPC UA was started within, or the development of the OPC UA spec within the OPC Foundation. But for that, we then ended up creating Java SDK. So what was the story behind that?
Yeah, well, I could say that, of course, the classic OPC is still pretty much alive in the factory, but we kind of completed the components for that already a long time ago, and they haven't needed any improvements. Mainly also because the development of the OPC Classic specifications was finished. Instead, the OPC Foundation started working on the new OPC UA specifications, which were supposed to fix all the issues related to the Classic. First of all, that it was related to Microsoft DCOM technology, and the second thing, that there was no decent security features in it, and so on. And the first news we heard about OPC UA was around 2005, I think, and then we got contact to OPC Foundation and got information what's going on, and then we started inviting the best experts like Matthias Dam to Finland to these yearly OPC Day events, which we also started 2005. And then there was also researchers in Finland that were very excited about the new OPC UA development, and together we set up a joint effort here in Finland, which consisted of researchers and some companies. And together we wanted to start working on something real. And it turned out that nobody was working on the Java implementation of OPC UA. Unified Automation was already working with the C++ C implementations, and Randy Armstrong at OPC Foundation was working with the .NET implementation. But nobody was working with Java. And the researchers in Finland were experts on Java. So they kind of brought out this idea that why don't we start working on the Java implementation? And that's how it all started.
The project in which the Java implementation was actually made was funded by government. Nowadays, the organization is called Business Finland, and these projects typically have like start and they have like an end, and when they end, like the funding for the research organizations typically ends, and then the researchers, they move to the next projects. But the implementation was still there, and well, it was donated for the OPC Foundation, but otherwise a little bit abandoned, I feel. So there we saw like the opportunity to continue our development.
Yeah, as you say, like when the funding ends for the research institutes and universities, then they move on to something else. But we as a company, we felt that that's the start. If we finally established something, now we have something to work on and try to bring out something useful to the market and commercialize it. And so we picked it up from that. From the research project ended 2009, and I started working on the SDK development myself, very much trying to bring out now the raise the level of the implementation so that other developers could also use this functionality. Of course, after the research project, the level of the implementation is never like a full product level. So there's a lot of work to do after that, and someone has to continue. And we started working on our own with our own funding to finish it in the hope that there will be a big market for the OPC UA.
Yeah. So was it 2010 when we released like the first version 1.0?
Yeah. I think in January we brought out the client implementation, and already half a year later or so we had also the server SDK ready.
Yeah, and we've had high hopes that now we have something that will sell like a lot.
Yeah.
But we were quite early, let's put it this way. So, but still, like even the first year, I think we sold so many licenses that we felt that okay, eventually this will be a business.
Yeah.
But everything has been added during the 12 years. I mean, it's not the same product anymore.
It's not the same product, but also on the other hand, the basis is still the same. So the good thing was that I had already like experience of working on an SDK through this Delphi SDK for the classic OPC. I had like a vision how should this kind of component work for the developers, and maybe the way I designed the components for OPC UA were not like a natural or the same style as most of the Java components are defined. But we were following the other implementations of OPC UA SDKs, and on the other hand, I felt that we need to make them easy to use as possible, so that these like components, we have a UA client and a UA server, they do most of the job automatically themselves. And it's important that you can just like configure how they function, and then you can rely that they do everything they know, or about the communication they know, and do much or most of the stuff automatically, so that you can just configure the components and rely on them doing the job, so that you don't need to find out so much that how do I need to do these different tasks with it. And therefore I'd be very happy that I managed to like set up the architecture of the components pretty nicely, so we haven't had to touch that much. But of course, there's been a lot of features that we didn't have in the first versions, and in some major versions, like in version 2, we added HTTPS communication protocol, and then we started also working on the information models and bringing out code generators that can take the OPC UA type definitions and generate respective Java classes to work with. And all these kind of changes were evolving, and we actually ended up writing the code generator twice over the years. I think first for version 2, and then a rewrite for version 3. And then in version 4, we also had some like major changes. But we also been following the OPC UA specifications, which have been evolving over the years. So we started with version 101, then SDK version 2 was following OPC UA version 102, and then SDK 3, 103 version of the OPC UA specifications, and now version 104 of the OPC UA specifications is developed with SDK version 4. Like the OPC specifications, the SDK also hasn't had major changes, but more or less like new features coming up all the time and new functionalities and so on.
But also I think the OPC UA specification has changed a lot, and what I think is one of the major thing is that like in the beginning, like 2005 when the specification design was started, or like we got like the first ideas what it would be, like the core was the OPC UA client server, and that was it, and no one expected anything else, that OPC UA would be anything else. But now there is also this OPC UA PubSub, and also some WebSocket implementations, and the OPC UA is not anymore like the transport protocol, but more like the content on top of the transport protocols, and this path seems to continue, but in our SDK now we have like support for the PubSub as well since last year, and that's I think something that is really like being welcomed by our customers, and we are selling quite good now, especially the PubSub versions of our SDKs. But how do you see the difference? Like, are the future the OPC UA PubSub, or are they just complementing forever each other, the client server and the PubSub?
PubSub has been like a major change or improvement to the OPC UA world, and it took quite a while for us to first figure out what does it really mean in practice and how to incorporate it with the SDK, and also where are the main use cases for it. So we, in addition to adding the features, we also tried to blog about the OPC UA PubSub to tell why and where and how to use it. And it's still like something that people have to like discover where is it the most useful and how do you combine it with the client server communication. And in future we will see the new field level communication getting more attention in general, and the new field exchange specifications are based on using both client server and PubSub communication. The PubSub can be very fast for transferring data between different applications, but the client server communication is still very much required for configuring the components and calling methods and doing more like this synchronized request response type of communication with between the applications. So there we definitely see a combination of the client server and PubSub to be used in future. The other part of the PubSub is the MQTT version, which is more targeting the cloud communication, but I see that it will also be like more or less this kind of a message bus or information bus implementation that can combine all the systems within OPC UA communication in large scale. In the case where you have like tens or hundreds or even thousands of components that are OPC UA capable, when you can't connect them all with the client server communication to each other, but you have to have like a common bus or network where all of them bring their information and where they can also select information brought out by other components. And how do you manage that? That is mainly based on MQTT brokers and MQTT communication, but it might still also need like the client server to do like certain operations like to starting machines or getting like direct feedback from them and so on.
Yeah, so especially like SCADA PLC level, probably MES PLC communication.
Yeah,
will utilize client server forever, I feel.
Yeah, most probably because it needs direct feedback and the direct connection all the time.
Yeah. But if we go a little bit to your applications, so in addition to SDK, I think like we are even better known for the public about our simulation server, which is probably the de facto OPC UA server used by all developers and testers of OPC UA when they kind of like try to introduce themselves what OPC UA is. So like, where did we get the idea?
I think now that when you ask where did we get the idea, I think we got the idea already from the OPC classic simulation servers. Already in that era, there was different companies that produced simulation servers that were like good tools for playing with the technology without having any real devices or real connections to the factory floor. And we also brought out the OPC Classic simulation server, and it's still available, of course. But there were also other components, and they were all called simulation servers. And that's why we also picked this name, simulation server, where the idea is that we simulate an OPC UA server. Many people that are working with process simulation, for example, can understand it a little bit differently. It's trying to simulate the process, but it's actually not doing that, at least so far. But it's simulating an OPC UA server that could be a real simulation server, or a real OPC UA server. And this is first of all, it's important for any developer who wants to develop a client application and needs something to test that client application against. But it's been very useful for demonstrating OPC UA capabilities and teaching people to understand what OPC UA is in practice, and of course very important for us ourselves to also validate that our OPC UA implementation is correct and functional in all aspects.
Yeah, and a few years ago we really realized that there is a lot of people using it, and we are getting a lot of feedback also for the simulation server, and of course it was, or it's still free product for the basic use, but we decided then that probably for commercial use and with advanced features, we should create something commercial that we can also support then commercially. So we ended up creating the Simulation Server Pro, but I think the beef in the Simulation Server Pro is the information models, and also probably the adoption of OPC UA standardized information model by the markets. They are used more and more, but they're still probably only the early adopters are still actually using them more.
Yeah, that's true. So over the last years, it feels like the most development effort is put on developing these information models. But there are different organizations like the VDMA in Germany that is driving this development, and there's more people from different domains that are participating and really bringing their expertise to these models, and that work has been really extensive over the last years. And within OPC Foundation, we also have this harmonization working group, which is trying to keep it all together and make sure that the models are creating a good group together, or that different models are not defining similar things in different ways and so on, rather that we can collect common topics within the OPC base standards, and VDMA is also defining the machinery model nowadays, which is a common model for all kinds of industrial machines. And this is very important, but as you say, we still haven't seen them so much in use in real applications, in real products. But I think it's a generic problem that the industry is still rather slow to adapt or adopt these technologies. The slowness becomes from the fact that you need to first of all develop these features into all the products that are in the market.
Yeah.
But the product developers are not ready to develop everything right from the start when the specifications are ready, because they're working on a commercial basis and they don't right away have the customers for these products. So it's also the market is coming out only when the end users start asking for these features. But before that, the end users have to learn that this is possible, and they have to understand what they could do with this, and then they need to go finding these products. But if they don't find them right away, then they also become a bit reluctant to try out. So this slowness becomes from the fact that it's like a chicken and egg problem, that who has the first component that supports this, and then you can start using it, but because it's an integration technology, you can't do anything with the one product. You need to have the other product that also supports this.
Actually supporting the information models, then it makes no sense for the factory IT systems to support either the information models like out of the box. But for this, to resolve this chicken egg problem, we have for a long time had the idea about this our manufacturing gateway, which now has become Prosys Edge application, and there the idea is that you could kind of retrofit old OPC UA servers to new OPC UA servers with information models. That's of course like something that now can help to resolve the chicken egg problems. But how do you see other products that are in the market? Like how do they support? And have you ever heard about the machines that actually supports information models?
Yeah, not really so far. There's been a lot of talks and discussions and wishes from some end users, especially in the pharma industry, that they would really like to see this possibility to integrate different kind of machines in their production lines with minimal configuration effort. And if we could develop like common models for managing these machines, like delivering recipes for them, controlling the batch processes with a common model and things like that, it would be really like great to get into this world of plug and produce, where you can just plug new machines into the production process. They would like self-describe themselves to the higher level systems, which could like integrate them in as part of the process, and then start commanding them and sending recipes to different machines, that the recipes coming from the manufacturing execution system, for example, and so on. So the vision has been finally established by some end users, but still, like the requirement needs to be taken down to the all these machine vendors, that they will start supporting this idea. But it's still also there's work to do with the modeling. The machinery model needs to progress towards this, for example, and so on. And we already realized that not all the OPC UA servers support all the necessary features that would enable uses of information models so far. So also we need to see improvement on that front. But it's all like, again, connected together, that the development happens when there is a real need, but even when there is a real need somewhere, it takes time before it kind of taken down to the improvement of the products that are in the market. Yeah,
but on the other hand, I think many puzzles are there already. I mean, Siemens S7, 1200 and 500 are supporting now like Node.js2 XML format information models, so you can bring your own information model to those. Our simulation server, you can mimic any machine with an information model, so testing, or you can use it as a testing tool for your factory IT products to create like dashboards or whatever that are based on the existing component specifications or information models. And now with our Edge, you can convert the old retrofit or brownfield OPC UA servers to information models. So in that sense now, a little bit, I think the use of the information models has become like an option, at least for the market. So it's now more up to the end users to require those. And of course, you said in pharma industry that there is now really like demand and need for that. But on the other hand, there is, I think, this component specification in which like the companies from certain industry come together and define together like the information model. There is like several dozen of those as well. So should we expect like more machines to come out? It would be nice to see those at least, let's say in the SPS first or so, but so far not that many.
Yeah, we haven't seen that much focus given to that yet, but I'm really also looking forward to seeing the machines, the robot vendors coming together and showing that they all support this OPC UA for robot model and things like that. So that would be really a good way to show that now this is real and now you can really use this.
Yeah, and definitely one of the really key points now for the OPC UA and the success of the whole architecture to get now everyone on board using these.
Yeah. There's been, as I said, huge effort put into these models. We put actually several years of development effort to enabling the information model usage in the SDK, but also in the simulation server that you can really try it out. We know that OPC UA is enabling all kinds of modeling, but the counterpart is that is not just the implementation doesn't happen just like that. So I also understand why it's an effort for all the vendors to add support for the modeling features and of course it's also there's it's changing all the time in the specifications. There's more improvements coming out in there. So you have to also follow the development of the standard still when it's being changing. But
yeah, and I think all the decent commercial SDKs or OPC UA SDKs, they support now the information models. So in that sense, technically, it's possible for every OPC UA server vendor to create server with the information model. Still, of course, the project that has been done previously, it requires some updates for those, and many anyway rely on those PLCs and their implementations as well. Okay, but hey, I think this was the first episode of our Coffee with Prosys. Thank you all that have actually been watching the video until this. And I hope we will have great episodes also in future. But thank you and see you next time.
Yeah, thank you.
Thank you for joining us for another episode of Coffee with Prosys OPC with your host, Pyry Grönholm. We hope you enjoyed listening to it as much as we enjoyed making it. With OPC UA becoming more and more popular in the automation world, we hope to introduce more people into this technology. So, share this episode with the people you think might benefit from this information and help us spread the knowledge together with our guest experts. If you like this kind of content, subscribe to our channel and click the bell to be the first to see our new videos. If you have any questions for us or our experts, don't hesitate to leave them in the comments below. We will be happy to try and answer all of them. We'd also like to encourage you to let us know which topics you would like us to cover in future episodes. Join us in the next episode, where we get inspired by automation and fueled by coffee.